Hello all, welcome to this lecture on storage classes in C. Today we'll discuss what is a storage class and how the storage classes are used in C language. So storage class defines the scope and lifetime of variable or functions within a C program. Scope indicates visibility. That means in which part of the program the variable can be accessed, and lifetime indicates how long the variable exists in memory. These two things are defined by storage class of particular variable. So generally there are two kinds of locations in computer where the value of variable is stored. The first one is main memory and the second one is CPU registers. While your program is executing, these are the two places where the variables values are stored inside the memory. One is main memory and second one is CPU registers. So it is the variable storage class that determines in which of these two memory locations, in which of these two storage locations, the values of the variables are stored. So therefore, a variable storage class or variable is declared including the storage class as follows. First, we should declare the storage class, then followed by give a space, then data type, then space, then followed by variable name, end this with a semicolon. This is the complete definition of definition, or you can say declaration of a variable. So any variable should be declared with storage class followed by data type followed by variable name. So what happens when we include these storage classes in the declaration of a variable? Today we'll discuss in this lecture. So a variable storage class tells where the variable would be stored. I said there are two locations. Okay. So your storage class, variable storage class tells where the variable value would be stored. What will be the default initial value of the variable? What is the scope of the variable? That is, in which functions the value of the variable would be available or accessed. What is the life of the variable? That is, how long would the variable exist? Exist where? Exists in memory, in storage location. These four things are known when we declare a storage class for the variable. What are the four things? I repeat. Where the variable would be stored, what is the default initial value of the variable, scope of the variable, and the lifetime of the variable. These four things are known with the variable storage class. So there are four storage classes in C language. First one is automatic storage class. Second one is register storage class. And third one, static storage class. Then the last one, external storage class. These are the four storage classes available in C. So we'll discuss one by one with examples. So first, automatic storage class. So when you declare the variable storage class as automatic, okay, so then the variable with the automatic storage class will have these features. What are those features? First one, storage. Storage will be in main memory. It means that variable storage is allocated in the main memory. Default initial value, an unpredictable value. Generally, this unpredictable value is called as a garbage value. That means when we don't initialize the variable with auto storage class, okay, so then the garbage value will present in that variable. Then scope of that variable is local to the block in which the variable is defined. Then lifetime of the variable is till the control remains within the block in which the variable is defined. Okay, so it restricts to the block in which the variable is defined. Okay, as long as the control is in that block, the variable exists in memory. Once the control leaves that block, then the variable removed from the memory. Then what is the keyword used to define this automatic storage class? Auto. There is a keyword called as auto. In lowercase letter, we should write this AUTO, auto. So these are the features that will be contained when we declare a variable storage class as automatic storage class. What are those features? Storage is in main memory, default initial value is garbage value, scope is local to the block, and lifetime is local to the block in which the variable is defined. As long as the control is in the block, the variable exists. And the keyword used is auto. Now, how this automatic storage class variable is used in C programming? With an example program, we'll discuss now. So first declare the main function, and inside the main, I'm declaring a C. The keyword I'm using auto int. This is data type, then followed by variable name. K is my variable name, and I am assigning 1 to this variable. This is how the auto storage class is used in the declaration of a variable. So whenever we declare in this way, so immediately for K, memory will be allocated and the value 1 will be stored in that memory location. So where is the memory allocated? Inside the main memory. Where is the storage allocated for this? Inside the main memory. Then again, inside the main, I am beginning another block. So in this block, again, I am declaring one more variable with the same name K, using auto storage class. Auto int K is equal to 2. Okay, since this is defined in another block. Okay, so it will be treated as a different variable. Generally, in C, you cannot declare two variables with the same name within the same block or within the same function. Since these two are in two different blocks. See, the first one K is inside this main, and the second K is inside this block. This is the beginning of the block, open brace here. Okay, so when this is allowed in C, you can declare two variables with the same names in this way. Now when this K is declared, immediately again memory is allocated, another memory, 4 bytes of memory is allocated for this K, and the value 2 will be stored in that memory location. Okay, so that means now there are two memory locations with the same name K. Then again I am beginning one more block here. Then again I declared another variable with the same name K, but this time I assigned the value 3. Auto enter K is equal to 3. Okay, so since this is in another block, separate block, again memory for this is treated as a separate variable. So memory for this K is allocated and the value 3 will be stored in that memory location. Clear? So since I am initializing these variables, the initial values will be stored in this. If I don't initialize, then garbage value will present in these three memory locations. Okay, so first 2 points features known clearly. Okay, memory is inside the main memory, storage will be inside the main memory, and initialized values will be stored here. Otherwise, garbage value will be stored here. Okay, so scope and lifetime I will explain now. Just see here. So I'm trying to print this K value here. Now there are 3 memory locations with the same name K here. Okay, so which value would be printed here? Which value would be printed here? Since this printf is written inside this block, since this printf is written inside this block, what the compiler will do is, compiler searches whether there is any variable with the name k declared inside this block. Inside this block, yes, there is a variable with the name k. Okay, so then that k value will be printed here. Okay, so when you print a percentage d comma k, then in the output, what is the value printed? It prints 3, since printf is inside this block here. Okay, so this local variable, this is called as local to this block. Okay, so this local variable will take the precedence, and this value will be printed. That means the memory location, this memory location is accessed now. This memory location is accessed now. Okay, so that means what is the scope of this variable? Now see, this is beginning of the block and this is end of the block. So that means this k is visible from the beginning of this open brace to end of this closing brace. Okay, so that means within these braces, the value of this k can be accessed. Okay, so after printing this, then the control reaches to closing brace here. Okay, so that means it is coming out from the block here. Okay, so once that means as long as the control is within the block, this k is available inside the memory. Okay, so after printing this, once the control reaches to closing brace, that indicates that the control is coming out from this block. Okay, so once the control comes out from this block, the memory for this k will be immediately released or removed, you can say. Okay, so that means once the control comes out here, then just you can see here. So after the closing brace, control goes to the next statement. Okay, so then immediately this k memory will be released here. Okay, so then control goes to next printf statement. Say printf percentage d comma k. Now this printf is within this block. See here. Okay, so this is the now see here. Okay, so this is the block in which the printf is written here. This printf belongs to this block. Okay, so this printf belongs to this block here. Okay, so that means this printf access this k value. This k value it access. Okay, now this printf is within this block. It access this k value it access. Okay, so when you say printf percentage d comma k, then which k value it access? The k value defined inside this block. Okay, so k is equal to 2 on the output. You can see 2 printed on the output here. Okay, then goes to end of the block. Okay, so now it's here. This block ends here. This is beginning of the block. Okay, and this is end of the block here. Okay, so this is end of the block. So once the control reaches to this closing brace here. Okay, so that means it is leaving the block. Once the control leaves this block, immediately the memory for this k will be released. Okay, so this is removed from the memory. Now see, so after printing this, then after reaching this closing brace, then the memory for this k will be removed. This k will be removed here. Okay, so then again we have one more printf statement percentage d comma k here. So this printf is within this block. Now see, this is the block. This printf is within this block. Okay, so since it is within this block, now the k value accessories k is equal to 1. Okay, so that means it access this k value, and there is only one storage location containing named with a k. So obviously it access this storage location here. Clear? So then on the output you can see 1 printed on the output. Then say return 0, close. Okay, so this is end of your program or end of this block, you can say. Okay, so once the control reaches or ends the program, now when it reaches to closing brace of this main function, that means this indicates end of the program. Okay, so when the program terminates, okay, so then the memory for this k is also removed by the operating system. Okay, so once your program terminates, then all the memory for these three variables will be released like this. Okay, so that means the variables exists in memory as long as the control is within the block in which the variable is defined. See, this is one block, beginning of the block and end of the block. And here, this is the variable declared here. Okay, so this variable k is declared inside this block. Okay, so its scope is within this block. That means this variable k you can access only within this block, and the lifetime of this k is as long as the control is within this block. Okay, so as long as it is within this block, the variable exists in memory. Once the control leaves this block and comes here, then the memory for this k will be released. This is the behavior of a variable with auto storage class. Now we try to execute this program and we'll see now all these memory allocation and deallocation that is happening inside the memory and is not visible. Okay, so what is visible to us? This is the program, and when you run this program, and this is the output that is visible to you. That's it. Okay, so memory allocation and deallocation happens inside the memory, so that's why we cannot visualize it. Okay, but you need to understand the concepts, what is happening behind the scene. Okay, so you must know these things. So we'll stop here, pause the video, and watch the video. Whenever you have any doubt, and try to subscribe to my channel and click on the like button. Thank you.